Good afternoon, everyone. Welcome to the latest in a series of webinars presented by Applied Software. Today's session is focused on optimized factory layout in 2D. We'll talk about leveraging your existing 2D resources with Autodesk Factory Design Suite and spend less time drafting and more time optimizing and visually communicating factory layouts. This webinar is brought to you today by Live Lab Learning, which is a subsidiary of Academic Corp, a wholly owned applied software company, and created for the sole purpose of providing world-class training to inform, educate, and inspire with all things Autodesk. My name's Jeff Pearson, and I'm pleased to be your moderator today. We encourage you throughout the course of the presentation to interact at will. We love questions, and we have correct answers. So you'll see in the pane to the right, you'll see a question panel. Any questions or comments, please enter them there. We'll be tracking those throughout the presentation, and we have set aside time at the end for any Q&A that arises during the course of today's presentation. Be aware this webinar is also being recorded, and it will be available on our YouTube channel, which will provide the info on that as well. We'd like for you to take a look at our upcoming events. As I mentioned, this is the latest in a series of webinars. You'll see here upcoming, we have Understanding Software Networking, which is sort of a primer for those that need a little more familiarity with the ins and outs of networking. And then Simulation with Inventor Professional. This has been a particularly popular topic, so there are multiple webinars that we are presenting, and you see the dates here. Another one that we've gotten a lot of response to is the Camelot with Inventor, where we'll focus on high-speed machining and the integrated CAM solution for Autodesk Inventor. The dates are there, and my contact information as well. If any of you have any questions or want more info on any of these events, do not hesitate to reach out to me directly. Presenting for us today is our esteemed teammate Scott Hallmark. Scott is a seasoned professional. He has more than 20 years of experience in IT, network administration, CAD management, and Autodesk software leadership. He's been in the reseller channel for, I think, 6 years now, and we rely on him regularly for his expertise in AutoCAD Plant 3D, P&ID, Factory Design Suite, which we'll be talking about today, as well as Inventor implementations, demonstrations, and training opportunities. Scott has been trained in various 3D design packages, not just Inventor, but also SolidWorks, Pro-E, and Solid Edge. So his knowledge of the 3D world is exceptional, and he is the ideal individual to lead us through our discussion today. So, without further ado, I will turn the floor over to Scott. Everyone's microphones will be muted, so remember, if you have questions or comments, use the question pane to the right, and we will address those before the end of today's session. So, turn it over to you, Scott.
All right, thank you, Jeff. Let me swap over here to AutoCAD. And so, like Jeff mentioned, we're going to be looking at Factory Design Suite in the 2D environment to optimize, streamline some of the tedious work that you do inside of AutoCAD. Hopefully, if you're not using Factory, this is something that you're kind of looking at, testing the waters a little bit, and you might be able to see some functionality here that would benefit you, your company, and the bottom line. If you already are using Factory, you may be using some of these tools that I'm going to go over today, and maybe there's going to be some things in here you weren't aware that Factory would do for you. So with that, we're gonna be working in a pretty common data set that you've probably seen before. It's just kind of set up and it's ready for me to not have to do too much to it ahead of time, but allows me to show the functionality of the software. So for those who have not really used Factory and you're just kind of curious, I will briefly go over what we're looking at. We are looking at AutoCAD Mechanical, which is one of the base products that come inside of the Factory Design Suite. This is the splash screen, or the application launcher that you would get if you were to have the Factory Design Suite Ultimate 2015. And it allows us to do certain types of things. If we just want to generate a 2D layout like we're going to be talking about today, we have this button here that would launch the application, either AutoCAD or, Mechanical or AutoCAD Architecture. Both of those applications come with the suite, as well as several others that we'll look at in just a minute. We can do material flow analyses. We can do process analysis, which is using a 360 product or a cloud-based product. We can generate our installation drawings, 3D visual layouts, create 3D factory assets, either inside of Inventor, or we can also bring them in from other applications and create assets from those as well. And there's various other things, engineering reviews using Navisworks, interactive presentations using Showcase, and then of course photorealistic rendering and animation through 3ds Max Design. So all those applications I just mentioned are part of the suite that you would get with the Factory Design Suite. And you can see those listed here. So I could launch them from this Workflows tab, or I can launch them from the Applications tab, either one. Or I could go over here to Recent Files and look at some files that I have been working on in the past and open them directly from there. So I'm going to minimize this, get this out of the way, because I already have AutoCAD Mechanical up and I've got the drawing up that I want to work in today. So as far as an interface, if you use AutoCAD Mechanical or just vanilla AutoCAD or even AutoCAD Architecture, you'll notice in this there is a new tab that is particular to the Factory Design Suite, and it's the Factory tab in your ribbon. And it's going to have commands that pertain to what we want to do today, like transportation analysis, machine utilization, creating assets. And we'll also briefly take a look at this creating a process model, which is the 360 product I mentioned before. On the right is an asset browser, and this is where we can find assets that are built into the application, built into the software, that not only are local to the machine, but you also have cloud assets as well that we can go and pull in from vendors, customers, users of the product that have been posting their assets up to the cloud for you to be able to use and put into your factory layouts. So you'll see things in there from different CNC manufacturers like Haas, some ABB robotic machines are in there as well. You'll see just an enormous list of assets that you can choose, download if you don't have them already on the machine, and it's just a matter of seconds to download them and have them into your 2D or 3D layouts. On the left is another tool palette that's kind of unique to Factory, and that's the Material Flow browser. It allows us to basically set up various stations of our factory. You can name them, you can apply properties to them as well, and then we take those stations and we define products that are going to be made using those stations. And with those products we can define routes and where is material going from its raw state to its final destination, to a finished product. And so we're going to look at being able to take some of these things, some of these tools, and optimize our factory layouts. So it's not really a lot of guesswork. We're not having to kind of generate these numbers off to the side on a notebook or some other application. We can do this all from within AutoCAD Mechanical with the Factory Design Suite utilities. All right, so I want to start with one option that we have is just to be able to make a new asset. We want to create an asset that's going to be added to my user assets, which you'll see right over here. And it's one that either I may have downloaded this from a vendor website or it's something that I just created. And I just want to block it. So you can see right now when I pick it, it's just kind of, it's just individual lines. I can stretch it. I can, erase it, add to it. It's not a block yet, so I do need to block it in order to give it, a good name. So I'm just going to call this a typical work cell. All right, and so this is just, for a lack of a better term, it's just, we're just going to call it a typical work cell. I'm going to define the base point of this so that when I go to insert this in, it knows where to come in at what base point. I'm going to select the objects that are included in this. So you can see it's highlighting the images or the geometry that's on the screen. If I needed to go in and add some additional stuff to it, I could just click on the block editor and go and add more items to it. But this is all I need for this. I'm just going to select OK, let it create the block, and then I've got a button up here called Create Assets. So we can do this with any AutoCAD block you create, any AutoCAD block you download and bring in from a vendor website. If it's a DWG, a DXF, however you want to insert this into your drawing, create a block of it, and then we can create the asset. So I'm going to create this asset. And the really nice thing about this is not only can we create a 2D asset of this, but we can also create a 3D asset as well. So we're taking a 2D imagery, 2D lines, arcs, and circles, and converting that into a 3D object. Now, you're not going to get the same type of detail like if you were to download a robot from, since we used it already, from ABB, a 2D top view robot, and I decided to create a 3D model of that using this tool. I'm not going to get the detail that I'm going to see if I had downloaded a 3D model of that. I'm not going to get the detail. Basically what I'm doing is telling it a height. I'm giving it an envelope that it would fit in. So I'm going to go ahead and click this to create, to select the block, and we'll come down and find that block that I just made, which is this typical work cell. So I'll select it, and it's going to ask me for different properties. Some things are already filled out, like the asset name. Now we could go in and change this so it looks differently over here in our tool palette. If you want to give it an actual model number or something like that, you can plug that in. We can give it a part number, so if this is like PN001 or 011, give it a description, estimated cost. All these things can be added to this as well. And you've got additional properties, but right down here is where we can add that 3D option to it. Say this particular work cell is about 48 inches tall. I would put 48 in there. Actually, this is millimeters, so we would need to make that something a little bit better. Let's just go 250 millimeters for the height of that. And so when I go to sync this drawing, I'm not going to do this during this webinar, but when I go to sync this drawing to Inventor, it would take this 2D asset that I've applied a height to, or a depth, creating a solid, to, it would go ahead and create that in the 3D model inside of Inventor. We can go to properties. We can add more information, title, company, category, and so on as well. Create custom categories, or custom properties also. When I'm finished with it, I can just click on Publish, let it publish this into my user assets. If this is something I want to make available to the cloud so that others can get to it as well, then I've got a cloud option too. If I want to put this under a particular folder, add a new folder, or remove the selected folder. You've got some options there, so you don't have to go to Explorer first and start creating folders inside of Explorer. Just do it here in the dialog box. It's very functional. So I want to create that work cell. and we'll let it create. So while this is running, it only takes a few seconds, but it's going to put it here in the user assets, and it's finished. So now if I go over here to user assets and I take a look, I'll find the typical work cell right down here, and I can drag this. Let me see if it's still running. All right, here we go. So I'm going to take this and I'm going to drag this in. So here's one that I've created already. We can place that in and put it in, turn on ortho, and go ahead and place as many of these in as we want to for this work cell. We can line it up with existing components, and this is now an asset that I can use. I'll delete the old one out, and this is an asset that I can use and have it automatically show up in 3D as well, because I've given it depth and those various properties. So now I want to show you another tool that is kind of built into factory design, and that's being able to place chain assets. Now, a chain asset is nothing more than a regular asset that duplicates itself. So I'm going to come back over here to our system assets. I'm going to come down to our let's see, conveyors, and I'm going to come down here to the roller conveyors. And so you'll see this icon that shows up in the corner of this roller conveyor, and it even has chain written in parentheses out beside it. That's letting me know that this is a chain type component, not meaning it's a chain conveyor, but it's still a roller conveyor. But I'm going to be able to place multiples of these with your 90-degree turns and all that with a very simple operation. So I could do this by clicking this. Clicking and dragging this in, and you see what it's going to prompt me with. It's going to prompt me to either draw a polyline now, or I could use a polyline that I had already defined, had already drawn in. So I'm going to do one first with me drawing the polyline, and then I'm going to do another one after and draw in a separate polyline to do that. So for instance, if I wanted a chain conveyor that kind of started here next to these machines, I'm just going to draw this in and say have it come down to this area and come over to the right and stop there. All right, what I've just created is a chain conveyor or a chain linked roller conveyor. So when I go to a sync Inventor and go to create this, you're going to see Inventor go automatically start placing those components in. It will shorten any that it has to shorten. It will lengthen any that it has to lengthen. Now I can also do this with just a polyline command, just a simple PL command. So we want to generate another one. It's going to come across here. It may come up a little bit and then go across in front of those conveyors, and then it's going to drop down and go over here to this area, and I'll just stop it there. So this is a polyline that I'm defining the location for this chain roller conveyor, chain linked. So I'll just drag this in. Again, it wants me to start drawing a polyline, but if I've already got one there, it's just a right-click option. I can go to Polyline, pick it, let it generate, and so now this is going to be a path that Inventor is going to automatically create. So I'm going to go in, sync this drawing to Inventor, so that you can see this automatically generate in the 3D. This will be the only 3D stuff I show you today. So let's save this file. It's going to close the file, and it's going to open up Inventor. You'll see that splash screen show up here in just a second. There it is. And then we'll see the Inventor model start to automatically populate that roller conveyor inside the model. So this is going to simplify a lot of what you do inside a factory. Before, what we would do is we would place a straight length of conveyor. Then we would place another one, or we would copy it, and we would have to, line it up endpoint to endpoint on the O-snap, and then we'd have to go drag in a 90 and have it turn, and then put more straight runs in there, and possibly another 90, until we had everything drawn in, and that was a very time-consuming task, even though it was still a very beneficial task, so you can see them start to come in there just underneath that dialog box. They're bringing in the 3D model for those conveyors. So it was a very long task, but at the same time, because we were still doing that inside of Inventor, it was going to automatically generate the 3D model for us. Now it speeds it up even more in that it's going to generate, all we can really need to do is just define a path. We could dimension, locate that polyline exactly where we need it, but still you see how quickly it's going to generate that 3D model of all those turns, all those straight runs of that roller conveyor instantaneously. I mean, it's just, this is a huge, huge improvement to the factory design utilities and commands. So while this finishes up, we're making our last couple of turns here. You'll just see those drop into place. And underneath, when it finishes generating this, you'll see underneath the polyline path that I had drawn in. And another great thing is that when I go back to my 2D model, you're going to see the actual conveyor there, not that bold polyline. So it's going to finish up here. We're going to start to see the 2D show up underneath. And there it is. So I'll zoom in to this real quick, and you'll also see the other components that I had placed in from the asset that we created. So I'm going to zoom in and let you see the conveyor that's in there real quick. Again, this is the only time I'm going to go into the 3D. Let it finish up here. Okay, so there's our conveyor. You can see the ones that were modified. It highlights the ones that were modified that it either had to shorten or lengthen in order to get this polyline to create the members, to create the assets, which is a great tool. I can tell exactly which ones are not the standard conveyor. All right, so I'm going to go back into my into AutoCAD. And I'm going to open that file back up, and now you can see that it has automatically turned that polyline, that thick polyline, into the conveyor members that and assets that we needed to have in there. Great tool, great addition to the Factory Design Suite. So we'll go from there to what you can do with analyzing your factory layout, whether it's looking at transportation analysis or machine utilization. We'll start with the transportation analysis. So it's just a toggle here to go from one to the other. I'm going to make sure we're on transportation. So you'll see here, based on this particular layout and the routings that have been set for a particular product using the stations that we've created, this is the route that this raw material is going to follow until it hits its final destination. Okay, so it's ready to be, it's in a storage out or a finished product. And you can see the arrows and how this route is actually moving along. So we're going from, actually I'll come over here and do it from here so you can see storage in, head rough machine. So this is our storage where we're starting, head rough machining, the exhaust, intake machining, goes over here to a cleaning, to a coating application to the left of that, and you'll see it jump all the way back over here to a leak testing operation. And then it comes down to the far left at the bottom for assembly and then storage right here. So obviously we see that there's some definite things we can do as far as moving some items around to help optimize this layout. Now I'm going to real quickly, I'm going to point out a few things that we're seeing here on the left, bottom left here. This is your transportation costs. It's cost based on the selection. So if I'm looking at this particular route, I'm looking at the transportation cost for that route. They're derived from several variables that can be defined. You can also go in and modify the transportation settings. So if I want to look at the intensity type, part quantity versus part quantity times distance, transportation cost, we can adjust those numbers there. Here we're looking at the total cost. What is this is a graphical dashboard that's letting us know the transportation cost plus machining costs for whatever we have selected. Then here we have a total travel time. So based on the distances we're looking at, how far different stations are apart from one another, this is the total travel time and travel distance that a part is going to have to go from start to finish. So we want to optimize this. We want to get our time less. We want to get our travel distance minimized, and we also want to tweak some of the assets that are in here, some of these stations that are in here, so that we may need to replace machinery with something that works faster than what's in there at the current speed, or we may need to double things up. But first thing we can do is move things around. We're going to see immediate changes down here when we start to move things around. So let's start with that. I would rather have this final product end up over here on the left, so I'm just going to select those. I'm going to select those items just with a crossing. I can do a window or a crossing. I'll move it. So I'm moving. You can see as I'm moving that my arrow also moves with it. That station identifier is also moving and modifying the location. This station up here, I'm just going to window around it, and we'll move that one to a new spot as well. So I'm just going to pick somewhere in the middle of there and move it to a location down here. Now we can be very specific. I'm just kind of eyeballing a location at this point, but we can be very specific with this and have this located on specific coordinates, however detailed you want to get. But my goal at this point is to get this number down, and eventually get my cost down for a product to run through its course. So obviously we went from almost 18 meters for a distance down to just under 11 meters. Our time was cut significantly as well. But now you see these indicators that are showing up. We had more than those before, but what these are, this is the indicators here are letting us know where we're seeing bottlenecks, where we're seeing places that we could adjust and optimize in order to get a better solution. So when we see red's bad, green is good. So I want to try to manipulate some of this a little bit. But first, let's go over here to our operations, our routes inside of our route, our different operations, and look at how things are going from point A to point B. So we're starting here with this raw material. It's moving over to this head rough machining station here. And if you look down in the factory object properties, you'll see that it's looking for a transportation type. This is being transferred by human. Someone's picking it up, taking it over, and putting it in a new position into the new station. We can certainly speed up this process either by adding conveyors like I did up here, or we could add a fork truck, have it carry a pallet of parts. However you see is the best solution for this layout, put that information in. So if I want to go with a conveyor, you're going to see not only our time change, but we're going to see costs go down as well. We've got some other properties down here. Let me move this up so we can see everything. So we can have a unidirectional conveyor, we can have bidirectional, we can have a continuous flow type or a discrete, meaning it only runs when it needs to. We have those types of options. I'm going to keep going down through here. Not really talk through these, but you'll see what I'm doing. Just changing these all to conveyors at the same time. Be watching these numbers here, and you'll see them change as well. We have just a few more to do. May even change one of these to a forklift just to show you the difference in the time and the cost savings on those. So this last one here, the assemble, I'll change that to fork truck. So by using a fork truck, it actually added 5 more minutes to the time, but that may be a more beneficial option for us or for this factory layout. You just have to consider what your options are and what's going to be best suited for this operation. So as I changed some of those things, you saw some of these items begin to turn red, and that just means we need to look at some of the more particular items of that particular station, the travel speed, the cost rate, the load time, the unload time, the processing time at the station. This is set to 8 minutes. If I could find them, add this row to it as well, maybe cut my processing time down to 4, is that going to affect anything? Is it going to help optimize this solution for me? So these flags that you're seeing, those flags just denote station intensity. Numbered flags indicate the stations with high intensity or high material flow. They help you to quickly visualize stations with potential for improvement that can improve your transportation costs. So that's that end of it. That's the transportation analysis. Now we can also come over here to a machine design, or I'm sorry, machine utilization. And so here we're looking at, it looks like all of my stations are well utilized or underutilized basically. I can go to any one of these flags that you're seeing here and add that particular meter to the dashboard. So you can see here what the utilization is based on the information I've given it. How many items are coming to it? How quickly is it processing it? What is the travel speed, the cost rate, all this good information down here. Am I overutilizing or underutilizing my stations, my cells? So I'm going to come over here and add this one as well. And we'll add one more. So you can add as many meters to this as you want, or take away what you want to take away. It's totally up to you which ones you include. All right, so I've got my meters in there. You can see that, this one labeled 61. These are not really overutilized, but they're more utilized than this one here. Okay, so it lets me know that I could possibly even I may need to double up here, or I may need to look at the machinery that's actually in this station and see if I can do something to improve the speeds, get another type of machine, whatever that the process is doing. Gives you an opportunity to evaluate and make adjustments. This is going to be helpful for you to show to your customer, to the owner, and let them know that you're going to get, this is your best solution here. If you want to change the route, we can change the route, but here's what's going to happen, and that's what you can do in front of the customer and let them know, why is it best to do things a certain way. So that's some of the tools that you'll find in the factory layout or factory design suite for 2D. Now, if we get out of AutoCAD, I want to kind of show you one more thing that's a really great tool, and that is this process analysis 360. You could actually launch this from here, create process model, or you can, if you have a browser and you can go and you have this as part of your subscription, you can go in and just launch this and start to create your own process analysis. So we're outside of AutoCAD. We basically come into this product, and we can add sources. So if I wanted to add a source, basically a storage, a rack where my raw material is going to be, this rack right here is one of my sources. Then you can come in and add a processor. That would be like this angle cutting machine or CNC lathe or welding cell 1 and 2. Then you got a rack where basically a storage or a buffer And so we have these buffers here that we can add in between our different stations. So we can see if things are going to be overutilized or underutilized based on properties. So if I go to this angle cutting machine, I can go to the properties of that angle cutting machine and look at the time to failure, time to repair. We can adjust those numbers. We can adjust the utilization alarms on this. If it's under 20% utilized, let me know. If it's 100% utilized, let me know. We can change that to 80. If it gets around 75%, we can change that to, I'm going to add 75% to that one. Then you've got the operation itself. What's the setup time for this? What's the processing time? How many parts can I have in this machine at one time? Is it just one, or can I have 5 or 6? And based on these numbers, it tells you what your production rate is. This is going to do 12 an hour. We can adjust the colors of the inputs, and so as we start to simulate this, which is what we're going to do next, we're going to simulate this so we can see how long is it going to take for 200 items to get made from raw material to a finished product based on this process, the properties that I've assigned to each one, and then a period of time. So I'm going to start the process. This slider that you see at the bottom actually speeds up that process. This is a really slow moving process at the moment. It's going to take us a while to get to 200. So I'm going to just drag this slider, and you'll see it start to speed up. So here I've realized that my utilization is I'm getting a flag on that. It's highlighting it red. What if, because of something happening to this particular machine, I just need to power it off? Well, now I can still see, based on my time down here, this is hours, minutes, and seconds, I can still see that this machine is still running while this one is down, and I can see what kind of throughput I'm getting to the end. If I decide to bring that machine back online, we'll see those numbers start to increase more because we have full operation again. And we're starting to see here that we're underutilized in this rack, this buffer. We're going to start to pass that threshold here in just a minute when it gets over 20%. And so that rack is, if everything is fully operational, we're seeing this this utilization increase, which means that I may need to increase capacity for the racks because it will eventually fill up, or I may need to add another welding cell here to my process in order to keep this at a steady percentage. It gives us those options, those flexible options where I can see it took me 18, almost 19 hours to generate 200 parts based on the information that I've given it. So you want to investigate this tool as well. It also generates reports for you, so once you run that analysis, we can come over here and view the report that it generates. And it's going to give us information on all of our different our processors, our buffers, anything that really we want to look at the details. So for that CNC lathe, it's doing 5.92 items per hour based on the information that I've given it. It got through 112 units. And so this type of information is very critical, very important to someone that's designing factory layouts. So want to make sure that you knew that this was also something to look into. It is a subscription type item, something you need that you would have to add to your 360 account, and Jeff can certainly provide more information. Anybody from our manufacturing sales can help with that as well. So with that, that's really all I had to show at the moment. This was going to be a pretty short webinar. So with that, I'm going to see if Jeff is still with us. If he is, we can address any questions that might have come in.
I am still here full bore, Scott, and
okay.
Thank you for that. Haven't seen anything pop up in the Q&A pane to this point, so don't be shy if there are thoughts, questions, comments, anything that any of you would care to bring to the table at this point, we're certainly glad to address or answer or help with any of those. And this would be the point perhaps where I say, anyone? Bueller? Okay. Give it just another second in case someone is in the process of typing. But while we're doing that, certainly want to thank all of you for taking the time to join us for this session today. Don't forget, check out our Live Lab Learning channel on YouTube. There you will find many, many recorded webinars and various other pieces of helpful information. Do not forget to check out the Live Lab Learning site, where you'll find all of our various training offerings that cover virtually the entire family of Autodesk products, the course syllabus for each, the requirements, and so forth, as well as availability and dates. So be sure and check that out. And I don't see any questions, so I guess at this point we will call it a wrap. Any of the upcoming webinars that you want information on, again, my name is Jeff Pearson. I'm part of the Manufacturing Technology Group here at ASTI, and I am happy to help or provide further info. Oh, wait, we do have a question before we wrap it up here. And let's see. All right, let's go back up here and just pull this down. One question we have, I've seen the feature for 2D asset connectors in articles about Factory Design Suite 2015. I'm working in 2014 at the moment. Would it be possible to get that feature in 2014?
Let me look at that question again over here. I'm trying to drag that out onto my screen so I can see it. Okay. Seen the feature for 2D asset connectors in article. Oh, yeah. That's something I'm going to have to look at. I'm not sure if we can get that into 14 or not. I believe that was a new feature, a new feature for 15. Typically with new functionality that's added in new releases, they don't give options to add that back into previous releases. That would be the point to go to the new release. So I'll have to check. I feel pretty confident in saying no right now, but I can certainly check that. This is from Stuart. So if we can get his information from the list of attendees, I will try to find an answer to that and let him know.
Yeah, just follow up with me, Scott, and I will. And thank you for that question, Stuart. We will get a definitive answer for you and forward that along in short order. Okay, let's see. I don't see any other questions at this point. Of course, it is still open. And you're more than welcome, Stuart. Thank you for the question.
Yeah, he has one more that just came across. It says, would it be possible to control the parameters of an asset in the 2D workspace as is possible in the Factory Lab 3D, either 2014 or 15? Actually, no, because they are blocks. They are, now that I'm thinking about it, I'm wondering now if we could possibly do that with a dynamic block. I've never tried that, but it just kind of came to me. I probably would need to try that. But because it is a block in its basic terms, because it is a block, it's not parametric, and unlike the assets in Inventor. So the workflow that I've used is if I'm working in 2D first and I'm designing in 2D first, I'll plug that in, that item in, I'll sync it to Inventor, go to Inventor, make the change in the 3D, and then have it sync back to the AutoCAD, so that those parametric values will redefine the block inside of the 2D. But now that you brought that question, I really never thought about it before, being able to go in and possibly make that dynamic, and I would just need to test that out. And he says, here's to hoping. So, yeah, I agree. All right, well, I will try that.
Oh. All right, let's see. Any other questions, thoughts, comments at this point? And doesn't look like we have anything else popping up. So, again, Stuart, thank you for your input, and we will follow up with you on those issues post-haste. Again, thanks to each of you for joining us today. We hope you found the session helpful and informative. It is being recorded if you care to refer back to any of it on the YouTube page. And we'll look forward to seeing you in some of our future sessions. Anytime any of us at ASTI can be of service, do not hesitate to reach out. We're always glad to help. So with that, we'll bid you a good afternoon. Thank you for your attendance, and have a great afternoon, folks.